This talk is going to be external SMS applications using SMPP. Who in this room have used SMPP so far? Okay, yeah, that's a considerable part of the audience, so this is probably going to be very quick in that case. If we look a little bit at the history, we started with the Osmo NITB, the network in the box. You know the old diagram and the old architecture. So this meant everything was included, the BSC, the MSC, the HLR, also the SMSC. And we added, or Andreas actually added, MNCC, the mobile network call control interface for external call handling. And we also added SMPP at some later point as an external interface without typos for external SMS handling. So initially you could only send SMS from the VTY if you're an administrator of the system, or from one phone to another. And then we added SMPP support to be able to send and receive SMSs from external entities. And now in the new disaggregated NITB with individual components like OsmoMSC, that didn't really change regarding SMS. So we split the BSC and MSC and HLR components, but the SMPP interface and the SMSC handling remained inside OsmoMSC. So we are not entirely disaggregated yet. So we have some more disaggregation to do before we can reintegrate everything to run a real network. Some people are, yeah, sorry, couldn't help myself. So, yeah, you can actually see here in this in the OsmoMSC box that the SMSC is actually here inside the OsmoMSC still. And that's not really great, and it's not, how can I say, how it should be, but it's just really the only, how can I say, aggregated part that we still have. So SMPP itself, the protocol, is not a 3GPP standard like most of the other protocols we implement, but it's a standard. I don't really like these. They call these things standard, but it's a standard by the SMS industry that some SMSC vendors have put together, because the 3GPP specifications basically say, well, some kind of interface external to an SMSC to some kind of application that's out of scope. So we don't specify anything, and that's basically left up to the implementer, whatever interface that is. It doesn't describe protocols or interfaces inside the GSM network, because then it would be in scope for the 3GPP, but towards external users. And they're called ESMEs, external SMS entities. It's basically how they are called. The protocol is a binary protocol. And since it's not an ETSI or 3GPP protocol, of course, the way how the encoding and the information elements work in there is, again, different. Rather unusual, I would say, and not particularly nice. There are language implementations for different programming languages. So there's libSMPP 3.4, which we use in OsmoMSC itself, or in Osmo NITB before. There is Java implementations, Python implementations, and God knows what. Unfortunately, SMPP is not transparent with what happens on the GSM layer 3 and above. So if you've worked with SMS at all, even on the mobile station side, like using AT commands to send PDUs, or basically to send SMSs, you know that basically you have to send or encode it in a PDU format, and that then as a hex string you submit to the AT command, which then the modem takes and transports further. And that hex blob, it's the RPDU, if I'm not mistaken, that is actually encapsulated in multiple other layers. So it's the TP layer and the CP layer in the GSM protocol stack. But that hex part that you provide is actually transparently passed through the network. Unfortunately, only inside the GSM network and not once it hits SMPP, because SMPP sort of doesn't sit at the same kind of layer boundary as in the 3GPP world. So it actually has also different coding schemes, not necessarily that there are different character sets, but it defines the coding scheme values differently than the coding schemes on the GSM side. And it has a different encoding of the messages from the TPDU format or from the RPDU format, which, yeah, is really not nice. I mean, I'm not saying this is stupid. I mean, SMPP was not specifically developed for GSM. It also supports CDMA and other, or was intended to support other types of networks that have SMS-type services, but which may not be based on the 3GPP standards for transporting or implementing those SMSs. So they try to bring the grand unified theory of text messages, and that then means it's not specifically related to GSM anymore. So yeah, so it's not nice from that part, but I will get back to that shortly later. So what can you do in order to use SMS on a OsmoMSC NI? That's the cellular network infrastructure, which is the name for the disaggregated NITB. So you can send, of course, SMSs from one firm to another. As I've said, it's the most natural way to transmit SMSs, but of course it requires radio resources and is slow. You can send SMS from the VTY, which is not really useful beyond development and testing, as the VTY is a human user interface, or how the 3GPP would call it, a man-machine interface. And it's not intended to be used programmatically. Also, it can only be used to send text messages and not for multi-part messages, so it's extremely limited. So the real way to do it is well, there is one undocumented way. You could just use the SQL table directly and put the SMS in there, but that's not really documented or supported or encouraged. So yeah, SMPP is the way to go. How is this configured in the OsmoMSC? You basically have an VTY node for the SMPP protocol, where you specify the TCP port on which SMPP should bind. I think 2775 is the standard port as per the SMPP specification. Then you have to specify the system ID, which is sort of just a name for the SMSC, how it identifies itself on the protocol towards ESMEs. And then there is a policy setting which determines whether you dynamically accept any ESME that may ever connect to that interface without any security checks or whatever. So anyone who connects to that SMPP port can basically say, hello, I'm here, and please send that SMS. Or we can set it to closed, and closed means that only ESMEs which are explicitly defined in respective ESME nodes in the VTY interface will be allowed to connect successfully to that interface. And for each such ESME, you then define an ESME node with a name, and the name is the system ID of that ESME. So that name will have to match on the configuration of OsmoMSC and the configuration on your ESME on the external SMS entity. You can also configure a password. And as you can see, I fell asleep after the set the password. So basically you go to the beginning of the line again. That's a plain text password. That's how SMPP is specified, not really adding really much security. I think it more helps you against wrongly configuring something rather than performing any kind of security. And then for each ESME, you can define routes, and the routes will define which phone numbers, destination phone numbers, will be routed to that ESME. So when a mobile station sends a SMS, then the routing table is consulted based on the destination phone number that you send that SMS to. And then if you have a prefixed route that matches the phone number in the SMS, then it will be routed to that given ESME. So you can have ESMEs for different numbers and implement different services or whatever that way. There's also a concept of a default route, which is a catch-all. So basically, if none of the more specific per ESME routes match, then the default route is used to deliver any SMS to any other not matching address to the ESME in which the default route statement occurs. So you configure basically all these things on the MSC side, and then you're ready to go. You need some kind of external application, some ESME to interact with. I'm going to show some Python examples here, which are actually, as you know, those of you who have looked at git-osmocom.org in the web browser will notice this is copy and paste from the CJIT syntax highlighted rendering, including the line numbers. So these are the actual code examples that we have in Osmocom Git, this slide, and the second slide for mobile terminated SMS. So that means SMPP originated, mobile terminated. That's actually taken from the mncc python.git repository, where there is a small example how to use SMPP. And so I just didn't cover all the import statement. I mean, you can look at the detailed source code, but the important part is basically you initialize the SMPP library client, specifying the IP address of the MSC and the port number of the SMPP port number of the MSC. And then you can set a couple of message handlers. I mean, that's really optional if you want to have some callbacks here initialized. At some point, you connect that client to the to the SMSC, which is in the MSC in our case. And then you have to call one of the bind statements. You can bind either as a receiver or as a transmitter or as a transceiver, and that will determine what kind of operations you're permitted to perform as an ESME. If you only bind as a receiver, you can always only receive mobile originated SMS. If you bind as a transmitter, you can only transmit mobile terminated SMS, or as a transceiver, you can do both. Not really clear to me why they did that, but that's the way how SMPP works. And as you can see, you specify the system ID and the password in that call to bind transceiver. And then this is just a simple for loop here that iterates over a couple of destination phone numbers and sends them the universal morning and lunch greeting in south of Germany. Yeah. So that's it. Of course, you can also send binary messages or whatever at that point. And these message handlers that have been registered, they will be called once some respective events have happened, such as the actual message has been sent and the SMSC has confirmed that the message has been sent and things like that. And it will just print a statement in this example. What we see, well, okay, there's a send message function that we call here, and how does that send message function look like? It's basically just has two different sections. The first is make parts, which basically creates multiple individual SMS messages in case the input string or input data is longer than a single SMS. So it generates the it generates the multi-part SMS. And then for all of the parts, which is the individual, like 163 character or whatever it is, SMS sections, it is building the PDU and sending it. So there is this client.send message, and you see lots and lots and lots of parameters that are specified. And that's the type of number is international, and the number plan indicator is ISDN, and the source address is 3802, and the destination type of number and numbering plan is the same, and the destination address is taken from the, you see, from the argument here, which is the phone number to which we're sending this. And then we have the actual short message and the data encoding scheme, and then you can also specify a mode, and the mode in SMPP specifies sort of the semantics of how the delivery works. So there is a store and forward mode, which means that the SMS will first be stored in the SMSC, and it will at some later point, whenever the network is ready, be delivered to the mobile phone. And we as the ESME receive confirmation at the time it has been stored to non-volatile storage in the SMSC, but we don't know it has been actually delivered to the subscriber. And there's another mode, which I currently forgot the exact name. Anybody here who can help me. There, I think it's transaction mode or something like that, where the SMS is actually sent to the destination subscriber, and only once the mobile station of the receiver has confirmed, has acknowledged the SMS, then the acknowledgement propagates back to the ESME. So that's basically, if you receive an acknowledgement in that mode as an ESME, you're sure it actually has been received by the phone, whereas in the other mode, you're only sure that it has been queued inside the SMSC. That's the difference here. For mobile originated side, again, some code snippets. This is actually from Osmo GSM tester source code, which implements also tests for the SMPP interface, of course. And we first define a message received handler, which basically is a callback function that is called whenever a message is received from the SMSC as the ESME, which doesn't do much more than write some debug statements here. Here is a function, this is part of a larger program and larger class definition, but you can see in terms of SMPP here that, again, we create an SMPP library client with host and port. We set this message handler and the message received handler. We connect to the SMSC. We call bind transceiver again with system ID and password, so that's all identical to the previous example. And then basically we do this start listening call. And that means the loop of the libSMPP will do its thing, and once a message is actually received, mobile originated as a message is received, this message received handler will be called and will do whatever it's defined to do. So that's basically how you can use the SMPP interface. There's a couple of extensions that Osmocom has implemented compared to what the SMPP standard specifies. There is a way how the standard can be, or the SMPP can be extended with vendor-specific information elements, and that's what we do in some of the cases. So there's one flag called deliver source IMSI, which basically means that the SMS, when received, a mobile originated SMS, when received by an ESME, will have a type of number and numbering plan indicator for IMSI rather than MSISDN. So the source address of the messages that we receive is the IMSI of the sender and not the MSISDN of the sender. This might be useful in some applications, but it's either or. There's no way to do both at the same time. Then we have some extensions that are really NITB only, which would tell you the ARFGAN receive level and receive quality and so on of the radio link parameters through which the SMS was received. That was needed in some special use case, so it was added. But that's really in the NITB only. The IMEI, I'm not sure if we do that in OsmoMSC. We could. I'm not sure if it's supported to also include the IMEI of the subscriber. There's another flag called DCS transparent, which means we will violate the SMPP specs and will use the exact definition of the data coding scheme in 3GPP, even in SMPP, rather than trying to do some sort of not really one-to-one mapping between those different data coding schemes, which has all kinds of room for interpretation, let's say. The other thing that we do in Osmocom, and I think it's not even an option, it's sort of automatic. Every time a location update happens with any of the subscribers, you will receive an SMPP alert. And in the SMPP spec, normally the way how it works is you can register for an alert. Basically, an external SMS entity can say, well, tell me when subscriber XYZ is around. And then an alert will be generated, so you can send whatever pending messages your application may have or whatever. And in the Osmocom implementation, both in NITB as well as in OsmoMSC, the SMPP alert is generated unconditionally automatic for every subscriber. So you basically get this continuous feed of location updates translated into SMPP alerts, which would allow an external application to always then check if there is some messages pending or whatever for that given subscriber. So limitations of that, well, the SMSC inside the OsmoMSC assumes a network that consists only of a single SMSC, and that means also a single MSC. So it's not really scalable. We don't have delivery reports in there. We don't have any roaming or interworking capabilities. And luckily, Vadim is working on fixing that, which will pave the way for doing a real external OsmoMSC or third-party SMSC, which can then also be shared by multiple MSCs. And sort of the reason is that SMPP is not really fit for all the use cases that you may have in mind. So it's really, as I mentioned, only between the SMSC and an external application, not inside the network. If you actually want something like inbound roaming, then you have a situation where the SMSC is in the home network and the subscriber is in the visited network, which is the MSC. And there's map encoded messages going back and forth, not only the MSC and the SMSC, also the HLR. And even if we ignore the question of how do we encode this in map, we still need procedures and transactions like in map for forward SM and so on. And that's simply not possible in SMPP. And as I said, Vadim is working on a GSUB-based SMS handling, which we will hopefully have in the near future, which would enable us to also cover such use cases. And then at this point, if the SMSC is no longer inside the MSC, of course, it would be an external entity, and you would still connect to port 2775, but it would no longer be provided by OsmoMSC, but by whatever external SMSC, whatever we may end up calling it. Yeah. Further reading, lots of links for Java and Python implementations and the specs and the GSM implementation guidelines. And actually, yeah, the link is broken for the GSM guidelines, but yeah, I leave that as an exercise to the reader. Any questions regarding SMPP? Please wait for the microphone.
Is it possible to have multiple ESMEs process one message, or does the delivery just end with a first match?
It is not a use case that I have come across. So, and I think also from the spec point of view, an SMS is a point-to-point message. It has one receiver and one sender. And also in our implementation, it's not possible at this point to deliver it to multiple ESMEs. But yeah, having said that, of course, you could copy it, and I mean, one could extend the code to make a copy of it and deliver another time if there is a strong use case for that.
So we use version 3.4. Are there any developments, further versions? Do they exist?
There is SMPP 5 and I think 5.2 or something like that. But I think I'm not really the SMS expert in terms of who uses what, but I had the feeling that 3.4 is a very commonly used version, which many programs support, whereas the more modern version or less ancient versions are not so universally supported. And they're not compatible, by the way. So they're completely different well, not completely, but yeah, they're binary incompatible, let's say it that way, to each other. So it's possible to implement, but nobody has ever raised that point. And as I said, it seems to be a very commonly used version.
Just sorry if I'm a little bit late. I'm arriving. Sorry if any of this was covered. I don't think it was. When delivery reports, did the delivery report code in the NITB not make it into the OsmoMSC? That's one thing. The second thing is with the SMPP alerts, I patched the NITB to do this to tell the difference between an initial IMSI attach and a subsequent location update, which is something that might be useful in our case. I guess if it could be added with a TLV or something. And another thing is just a comment that from working with the lib SMPP that you were describing, it could actually use a little bit of love. You can crash it with the wrong characters. It's the character translation encoding in it is not fully perfect if anybody wanted to take a look at it.
You're talking about the lib SMPP 3.4 in C or
no, the Python.
Okay.
Well, this got to.
Yeah, so there was a comment that it needs a complete rewrite. It's not my personal opinion. I don't have an opinion on it. I never looked at the Python library, to be honest. I only know the C library.
So the delivery reports?
Yeah, the delivery reports. Okay, maybe that was a wrong statement. It was my assumption. I didn't really check. Not sure. Niels is not here, unfortunately. He would be the person to ask, I guess. I don't think we test delivery reports. Do we test delivery reports, Paul? I think so. Ah, okay, good. So if we test delivery reports, then obviously we have support for that. So my assumption was wrong. Does it pass? I think so. Okay. So yeah, it seems we have a test and we have code and it passes. So according to hearsay, it's working. My apologies. There was there another point? Sorry, there was delivery. Yeah, and you have some patch. Yeah, sure. I mean, just submit it. It should be rather easy to. I mean, to add the differentiation between initial attach and periodic location update or normal location update, as in really changing the location. Sure. I mean, that can just be another TLV that's added to the message. Should be really straightforward. Can be easy to merge.
Just explain the use case in that was emergency networks where we wanted to send an initial message to the user when they initially connect, as opposed to sending them a message every time they periodically update. So yeah. it was, but I didn't do it properly. I just hacked it. So I guess it needs to be configured and etc.
Yeah, I mean, we're sending the alert anyway, unconditionally. It's also not configurable, but yeah, I mean. Anyway, it's certainly, it doesn't, you know, it's probably 10 lines of code or so to add this. At least that's my naive assumption right now. But I don't really see where the complexity would be to add that. So sure, we're open to that. Okay, any other questions on SMPP? No. Good, well, thanks.